Let's see last method, method 4, DFT IDFT method. So in this they have given two sequences x1 of n and x2 of n, each of length capital N. So using DFT IDFT method, we have to use following steps to calculate circular convolution. So first find DFT x1 of k of first sequence, find DFT x2 of k of second sequence, then take multiplication of two DFTs and say it as x3 of k, then find n point IDFT of x3 of k, so that you will get sequence x3 of n. So this x3 of n is nothing but output of circular convolution of two sequences x1 of n and x2 of n. For this we can say property multiplication of DFT is nothing but circular convolution in time domain, that is DFT of x1 of n circularly convolved with x2 of n is nothing but x1 of k multiplied by x2 of k. That means we can say in another term that circular convolution in time domain is nothing but multiplication in frequency domain. Again, for this example or this method, length of both sequences must be equal and append zeros if necessary. So we will see with one example, x1 of n 1 2 2 1, x2 of n 1 2 3 1. So first step, we have to calculate DFT x1 of k of x1 of n. For this we are using transformation matrix for n equal to 4. So multiplying, we will get x1 of k 6 minus 1 minus j 0 minus 1 plus j. Next we will calculate x2 of k using transformation matrix for n equal to 4. Here we will get x2 of k equal to 7 minus 2 minus j 1 minus 2 plus j. Next step, we have to multiply these two DFTs x1 of k and x2 of k. So we will get x3 of k equal to 42 1 plus 3j 0 1 minus 3j. Next we have to take 4 point IDFT. So again using transformation matrix for IDFT, we will get x3 of 0, x3 of 1, x3 of 2, x3 of 3 equal to 1 by 4 transformation matrix for IDFT multiplied by x3 of k. So simplifying, we will get 1 by 4 in column vector 44, 36, 40, 48. Dividing by 4 we will get x3 of n equal to 11, 9, 10, 12. So finally writing answer, circular convolution of two sequences is given by x3 of n equal to 11, 9, 10, 12. Don't forget to show arrow below 11 as it represents value of a sequence at origin n equal to 0. Now while solving this example using DFT or IDFT method, you can use any one of three methods. Either solve using definition of DFT IDFT, either use twiddle factor or use transformation matrix.